Hi everyone! We are going to talk about two issues related to memory allocations, memory leaks and memory corruption. As some background information, let's cover how C memory works. The memory can be divided in four segments. Text segment is where all instructions are stored. The program you have written is converted to an object file, and the lowest address of the memory is filled with the data. Initialized and uninitialized data segments. Located above text segment, the global and static variables are stored in this segment. Initialized refers to data that have been filled with some data value. Oppositely, the uninitialized data are only global or static data types that have been declared, but no value has been given to them. The kernel initializes them to 0. Stack. Opposite to the heap direction, this is where local variables are stored, and information about a function is saved here when it's called. When a function is called, the stack memory reserves some space for this function, and when the function ends, this space is wiped out by another call function. Heap. This segment is where dynamic memory allocation takes place, taking place after BSS segment, which is uninitialized data segment. This area is managed by malloc, realloc, calloc, and free functions from the stdlib header file. Its focus is to create variables with a size not contemplated by the designer.
Now that we explained how the memory works, it's time to describe what is a memory leak. Occurs when a computer program fails to release a resource that has accomplished its task, employing space that another variable could use. This is associated to memory allocation at the heap memory, because the stack memory doesn't increase its memory size radically. Instead, the compiler assigns the addresses that it needs, and they don't change. Back to the memory allocations, we need to know that the memory is not limitless, so we need to leave space to variables that we will use and free the memory we will no longer use. If we fail to free the memory, the application will run very slowly or even crash for not having enough memory. Some mistakes we can make are not freeing allocated memory if it's no longer in use. The variables will occupy in space, making it impossible to the other variables to take their place. You need to remember they use free every time you allocate memory. If you assign a pointer without being freeing or direction into null, the contact with the piece of memory you allocated will be lost and taking precious space. This can be fixed easily by freeing the pointer before use it to another purpose.
Another issue with dynamic memory allocation is the memory corruption, that is defined as the altering a piece of data held in memory without explicit assignment to the heap memory. In other words, changing data in a part of memory that is occupied by another task. A common example is freeing a chunk of memory we previously free. We don't know if the operating system assigned memory in that location after you free it. And if you clear that piece of memory, then you are erasing data allocated by the system. Another case is using memory out of bounds. If you allocate a number of space, be sure to only use those space, because the computer is very obedient on how you assign values in the heap memory. So if you overwrite information far away of the allocated memory, you will be overwriting another program's data. Finally, using a pointer that has been already freed will overwrite any info the computer is currently using on it. So here's the importance of setting to null a pointer if it has been freed.